This is number 11, and it asks how much heat is absorbed by a 1 times 10 to the 2nd gram of ice at negative 20 degrees Celsius to become water at 0 degrees Celsius. Okay, so I like to draw a chart. So we're starting at negative 20 degrees Celsius, and we want to get to 0 degrees Celsius. So we're going to have to heat it up till it becomes where it's going to melt. So our given you should convert mass to kilograms, so that's 0.1 kilograms. So first we need to warm up the ice. So our first step is to do Q1 is equal to MC delta T. So it's mass times the specific heat times the temperature change. So our mass is 0.1 kilograms times the specific heat of ice, which is 2060 joules per kilograms degrees Celsius. Then times our initial final temperature, which is 0 degrees Celsius, minus our initial temperature. So a negative is being minused. And then we get 0.41 times 10 to the 5th joules. Then part 2, we need to melt the ice, because when it gets to 0 degrees Celsius, that's when it starts to melt. So we're going to use our heat of fusion equation. So Q2 is mass times the heat of fusion. So our mass is 0.1 kilograms times our heat of fusion, which is 3.34 times 10 to the 5th joules per kilograms. That gives us 3.34 times 10 to the 4th joules. Now our next step is to add up all of our heat. So the total heat, Q total, is equal to Q1 plus Q2, 0.41 times 10 to the 4th joules plus 3.34 times 10 to the 4th joules. And our answer is 3.75 times 10 to the 4th joules.